All right, guys. Well, thank you to all of the automotive engineers and leaders joining today. We're going to be speaking about innovation, electrification, and the shifting factory floor print. And I am the head of business development. We have two others here that are joining us as panelists. Doug, do you want to introduce yourself? Rich,
Yes.
Go ahead.
Thanks, Sam. Hi, I'm Doug Myers, Business Development Director for Global Automotive with EWI. Also a Valence board member. Just a little bit about my background. Spent first 16 years of my career in manufacturing and operations and general management, focused mainly in two industry sets. One is automotive and the other is aerospace. And really glad to be part of this webinar today, and I hope you find it informative.
Hi, I'm Rich Barker. I'm General Manager of the Lexington Division of Valence Industrial. Some of you may have known us as J.R. Buck Industries, which I've been a part of for the last 4 years. When Valence bought out J.R. Buck, I was asked to become General Manager, and have been in this industry for over 30 years as far as custom manufacturing, and just very appreciative to be a part of this event.
Thanks, Rich. So in terms of the agenda, we're going to talk about the broad trends hitting the industry with Doug Myers. And then we're going to get down to the application of what does it mean for the factory floor print, as Rich talks about some of the case studies he's been running into frequently. So Doug, take it away.
Great, thank you. Well, we're going to cover 3 topics and would like this to be very interactive. So if there's questions or comments you'd like to make, I mean, there's questions that can be written through the WebEx, and then we'll address those as they come through. But we'll have a Q&A, I think, at the end of each one of these sectors. But I'm going to cover 3 trends. One is COVID and some of the long-term impacts. The next trend is Industry 4.0, smart factories. And then lastly is vehicle electrification, what's happening, and how quickly it's moving at this time. So many of us we've all lived through the last year with the COVID-19 pandemic, the challenges it presented to us. And I do have to say that for U.S. industry, very proud across all the sectors, not just automotive, how nimble and responsive the industry has been being dealt with, these challenges that we saw. That brought on a whole new level of working remote. It also drove the need for more automation. And then this thing of worker to worker versus worker to machine, found out that, robots don't get viruses. And so some of the strategies manufacturers took was to introduce more automation in robots, and specifically cobots, where people can work alongside a robot safely. And so that seemed to be a trend that was getting adopted very quickly and is continuing to do that. The last one, the digital transformation. It's moving things to the digital age with machines and robots learning and becoming smarter. And we'll talk about that a little bit. So near term, we've already dealt with this. It was workforce shortages. People work remote, some people couldn't. And so manufacturers had to adjust to that. The distancing all of a sudden changed kind of what safety and compliance means. The social distancing, the 6 feet, and we're dealing with that now. And that kind of disrupted and really had us reorganize our manufacturing facilities. And then the health and safety compliance changes. If we do, I do still visit manufacturing plants, but there's a protocol, testing beforehand, waivers and releases. So that, it's a real process to get anybody in the facility, even today, a year later. What it did do too is it disrupted the supply chains. We found out how reliant we were on the supply chains, and this just-in-time manufacturing that's been deployed for years. All of a sudden, you had no fat in the pipeline, so you had no ability to recover from shortages of material by having any safety stock. So people are rethinking the JIT a little bit, and we need to be a little more nimble and a little fatter as far as our supply chain. And then some of them is, the challenge is not to be so self-reliant. So some people are vertically integrating again. Instead of using suppliers, they're going to take it on themselves to manufacture subcomponents in order to be more self-reliant. So with that, I mean, I'm going to hand this over to Rich to talk a little bit about some safety and compliance things that Valence does for their customers, applicable to the changes that I just talked about.
Yeah, Doug. So basically, the case study we have here that we've done several times before, but this particular one was a company that did the design and had the concept for a robotic cell. And what they were needing from us was fabrication support of the supports that were going to hold the not only the robotic heads, but also the safety fencing. And basically, we're looking for us to come up with the design for the majority of the supports and the safety fencing that was needed. And basically what we did was take this information that was presented to us as far as with the robot heads, did a stress analysis on the materials that they were recommending. And basically we made some changes based on what we saw it was going to take to support the robotic heads. Then we came up with them on the design of all the safety fencing that they wanted fabricating, and as far as the entrance points, clearance, things of that nature.
Rich, we just got a question in. What were the types of weight limits with this project?
Yeah, so in the beginning, it was really unknown. And basically we had to get that information from the customer to do what I basically just said previous, was to perform some stress analysis on the materials that were going to be used to make sure it safely supported this, but would also be safe in the continual use of the heads. Basically we went to their facility, sat down with them, got the information as far as the clearance, like I said, of how the parts were going to move, how the flow was going to go, and then basically drew up everything for them as far as a floor plan for the total process. So for all you out there, do you see robotic cells becoming a larger trend in your factory location? And if you don't mind, fill out the questionnaire that has been put on the screen for you.
Well, it said just in our 3 or 4 seconds. Okay, I just ended the poll and I'll share the results.
So basically, here's the results. 89% or overwhelming majority of you say, yes, that's going to be a trend in the future. 11% said no. So when you look to this, I guess I don't know what each of you have as far as support there at your own facility, but again, being a good salesman, please contact us as far as anything we can do to help in that design of the layout of your facility.
All right, so we'll hand it over to Doug for the second trend.
Okay, the second one's around Industry 4.0 and smart factories. As I said earlier, and COVID kind of accelerated this, there's a certain move to move more to automation. With automation is to do some smart factory work as well, and leverage big data in order to make decisioning, as you're running the manufacturing process, making minor adjustments to improve quality, improve throughput and output, and then also kind of take advantage of the technology due to, the subject matter experts not being available or not, there's a lot of the highly technical people in manufacturing across all industries that are retiring. And there's that tribal knowledge that they've developed over 30 years in industry, 40 years in industry that quite frankly, isn't captured someplace. And so what subject matter experts you do have left, you can leverage them. You see the individual here working to train a robot and to program a robot, and somebody that knows this process very well, instead of being dedicated to one manufacturing cell, can actually manage multiple cells and circulate around the plant and make sure things keep running. But a lot of these smart factories are making minor adjustments on their own as they're moving through the manufacturing process. So the next slide shows a McKinsey report, big research, global research firm, and they're looking at different techniques to improve efficiencies across a multitude of industries. And what is here is that artificial intelligence, there's 15% of the industries they looked at that have no impact. Artificial intelligence or smart factories or smart trucks and logistics isn't really going to apply. 16 is necessary, and it's something that they're going to be building new plants, new capabilities, and then overwhelmingly almost 70% can really significantly improve performance, and using this technique versus other investments in capital or technology. And the next
Doug, I got a question in,
Sure.
and the person asked, with people talking about labor shortages, what should auto leaders be thinking of as they hire in new people?
Well, there needs to be a higher level of understanding of technology, maybe than is in the past, because of the automation, because of the robotics, because of the technologies. That person, needs to understand, doesn't need to be a programmer, but needs to understand, the capabilities, need to understand what the user interface is like, and be able to leverage, the technology. So I think, what's happening in some of the tech centers, the education centers, there's much more, emphasis on the technology and the adoption of that technology to manage the manufacturing process, whether it's quality control or just managing settings in situ as the product's being produced, through the cell. So this is a bit of an eye chart to take a look at, but the significant improvement in efficiencies, they're talking about trillions of dollars of value over 19 industries, and this is a time frame over the next, I think it's the next 10 years. But if you look over at the left, you see the biggest impact is going to be on travel, is the first one. The second one's transportation and logistics, which in automotive is, that's part of the supply chain and the movement of materials. And then automotive is, number 4. So significant, research into this saying this trend's coming, and it's going to have a super impressive impact on the throughput and efficiency in manufacturing, especially automotive and logistics and travel. So with that, hand it back to Rich to talk a little bit about some things related to that that Valence is doing today.
Thanks, Doug. Yeah, this was a particular case study that we did for a local tier 1 supplier. They were looking to kind of customize their way they were conveying subcomponents to line side processes. And they came to us, the high level scope of work was basically, we want a conveying system with mother-child carts where the child carts would all be cubed out the same as far as on the footprint, but were able to be customized as far as the holding details that would convey whatever the subcomponent was to different line side processes. So we worked with them as far as building prototypes, did a lot of form, fit, function at their facility as well as ours with these different components that were needed to be conveyed, and basically came up with a process that was able to save them a lot of fork truck traffic use in their facility. This particular project basically was about a 3-month project where we did a lot of the design. We took basically their part prints and then designed the holding details for each and every one of these child carts that were being used to convey to line side.
Rich, we just got 2 questions in. One was, how did they reduce the forklift traffic flow by 60% using this? And then secondly, was the entire car customized, or were there standard parts of it?
Well, the standardization again was the outside shell of the cart, far as the child cart. The customized part again was the internal holding details that were used into holding the particular part that was being conveyed. Some were hanging, some were put into bins, but basically what happened was they were able to get more parts on these child carts than taking. They were using another system basically that used about twice as much of the carts they were using, and they were able to basically, they had obviously an inventory of these where they had a market where they were loading these up, and then the fork trucks obviously come back and pick up what was needed, take the empties away. What was the second question? I'm sorry.
It was, how did they reduce forklift traffic using this different design than what they had previously?
Yeah, I think I alluded to that in the answer as well. So,
and Doug, how does this relate back to the broader trend of moving towards electrification and automation?
Well, there's different strategies. Some companies are going to be commingling their electric vehicles in with the ICE or internal combustion engine plants. Some will be doing greenfield projects and some brownfield as well, converting plants over to one or the other. What happens is, when you're moving materials around, there's a need for more space if you're going to have, commingled platforms running at the same time, electric and also internal combustion. So floor space is pretty valuable. So, the reduction of forklift traffic and having these dollies with materials being moved by hand into cells and out of cells is a lot more efficient, and, requires less aisle space to have these forklifts, rolling through the aisles of the plant.
And Rich, I think you were speaking to this earlier, but can you kind of help us understand a little bit more about some of the photos and where the standard versus customized aspects were to kind of cut down on that floor print?
well, again, the standardization, if you look at the carts themselves, every one of them had the same outside cubic dimensions as far as the outside frame. The outside frame was all built basically the same. It was the internal holding componentry that was different. I would say that by doing this, there were some changes even on down the road, that we were able to use the same skins, so to speak, and cut away any of the internal details that they didn't need or wanted to retrofit to a different model. Instead of having to go build a whole new cart, we were able to just replicate or design and put in new holding details that were needed.
Okay, that makes sense.
So ask the audience, so do you see your factory having an increased number of platform changes compared to past years? And I think that would take into what Doug has been talking about, not only your own platform changes with the way the vehicles are now, but even what will happen with the electrification coming on.
So we'll just give the poll just 2 or 3 more seconds. All right, I'm going to share the results now.
So we have about 70% saying that, yes, they will have a factory that will see changes compared to past years, or an increased number in platform changes coming in the next few years, where a few of you said no and the other said really don't know, which that's understandable. A lot of that sometimes is, as far as platform changes, come down from higher management as opposed to those of us out in the working field. So.
Okay, third trend, electrification, is already here. The pre-COVID, there was already a lot of disruption in the industry about the development around electric vehicles, and also hybrids. Also hydrogen, fuel cell is still something that's out there. And so, the COVID really kind of, I saw it with my customers, the OEMs and the tier ones globally. They stopped development or slowed development down of the internal combustion engine platforms because they needed to manage their costs during the pandemic. But the mood on the other side for electric vehicles or hybrids was full speed ahead. We are not slowing down any R&D efforts, and we're going to see the result of that later this year. That they were doubling down and investing the money they had, and they were all in on not making sure that there wasn't any delays from COVID for electric vehicles or hybrids or any of the other type of vehicle that we're talking about rolling out. If you look at the chart here, this was pre-COVID. This was from a car conference that I attended, and it talked about the adoption rate just in North America for electric vehicles. And what COVID's done to this, all it is, it's kind of flattened the rollout in 2019 and 2020 and early 2021, but it's pushed this into more of a hockey stick starting later this year and going out to 2027. So it's even more severe in this as far as the proliferation of this and what's going to happen as far as what we're going to see moving forward over the next 5 years. Everybody has a different strategy here. And I'm working with most, if not all, these customers on rolling out the development and the execution and the manufacturing for electric vehicles. There's some that build, they built from the ground up. Tesla was the first. Canoo, and on the West Coast, more of a delivery vehicle, built it from ground up. And Karma, really high-end automobile, mostly hand-built, over $150,000 for one of these platforms. They decided to build from the ground up. Others like Ford bought Rivian, invested in Rivian along with Amazon. And then recently FCA merged with Peugeot. Now they're called Stellantis. And that's how FCA got into the electric vehicle market, by buying Peugeot, who was very much in the electric vehicle market in Europe. There's others that are allying. Kind of weird, GM was early in the electric vehicle market with the Volt. And that was like 10, 12 years ago. We helped the development on the battery for that at EWI. And now GM's working with Honda to co-develop a platform. And GM's also working with Nikola, who's the semi-truck manufacturer that's hydrogen fuel cell, and then is going to have an all-electric version next year. Over-the-road trucking's moving in this direction as well. So, everybody's taking a different approach, but what you're going to see is today you have maybe 3 choices of electric vehicle. You can look at a Tesla, you can look at a Nissan Leaf, or you can look at the Chevy Bolt. The Tesla is a little sexy. The other 2 are kind of utilitarian. And what you're going to see by the end of 2021 in the fall, there's going to be a launch of 8 to 12 platforms. So the choices are going to go up dramatically as far as what you can choose from on an electric vehicle. So it's coming. It was going to be a year earlier, but again, with COVID, it's delayed it. But instead of 6 last year, 6 this year, you're going to see 12 platforms at the end of this year, and then the hockey stick going forward as far as the availability. Right now in the US market, electric vehicles make up 2%. But, so double or triple doesn't seem like that much, but it's considerable growth for, somebody that's at 2% today.
Doug, we just got a question in. From your perspective, are the OEMs ahead of the curve or behind the curve when it comes to supporting auto companies with electrification?
They're probably ahead of the curve. And the reason being is, if you look at what we're talking about automation wise, hitting some industries and companies that really didn't invest in it before because they couldn't justify it. And now they have to, because that's the only way they're going to meet demand, much less meet any kind of increase in growth, just because of the labor force shortages. The automotive industry has been investing in automation for many, many, many years. So the OEMs are pretty well positioned to, either they're going to build a new plant or convert an existing plant for electric vehicles or commingle them. And the tier ones are very much committed to automation as well. So they've already gone through this, trying to take as much labor force out of the manufacturing process. And they're very sophisticated, and they have large teams that focus on this for continuous improvement. And what we find from EWI is we only get involved with the OEMs when they don't have enough time to get something launched, or in some cases, they don't have a level of expertise that we do, like in additive manufacturing, for an example. But in automation and fundamental engineering, they have staff sizes that are larger than EWI's.
Mhm.
Okay.
One thing, Rich, if I can say one thing,
Sure.
To hand this off to you, what kind of wakes us up is the fact that if you're moving from an internal combustion powertrain to an electric vehicle or even a hybrid, that platform looks a lot different. And moving around powertrain components and assemblies in an internal combustion engine, the engine, transmission, and drive lines, that versus moving around a 2,000-pound battery tray and an electric motor, it's a much different dynamic as far as the size and mass of what you're moving around. So you just don't plug in an electric motor where you used to have an engine or a battery versus the motors. So this really kind of changes the dynamic, and it kind of challenges companies about how am I going to deal with this, and how do I move these materials, because powertrain looks a lot different with electric vehicle than it does today. So that's kind of where, Rich, you're going to talk about an application here.
Hey, Doug, before we move on, we just got a question. China is far ahead of the US, and there are significant fees to drive gas engine vehicles in cities. Their infrastructure has significant amounts of charging stations. Is there any hope for the US market to catch up to China?
Yes, I mean there's a lot of work being done on resources like hydrogen fuel cell stations, especially in California, because that's where those automobiles are being built and shipped by Toyota. There's also we have an oil and gas business at EWI as well, and oil and gas, the Shells of the world, they understand that the filling station of the future is going to be a combination of gasoline. It could be hydrogen fuel cell, and then it can also be battery recharging stations. So there's an infrastructure bill that's being pushed out right now by Congress, at least talked about. And in that bill is those type of infrastructure investments that has to come over the next 5 to 10 years in order for this to be supported, these platforms to be supported. So I don't know when we're going to catch up with China, but I think just like how we dealt with COVID, once we get on board with this thing, I think we're going to see things moving very, very quickly over the next 2 to 3 years.
Thanks, Doug. And Rich, to you to talk more about prototyping in the shifting factory space.
Right, and alluded what Doug is saying in his last statement before the question. With all these changes, prototyping is going to be key and critical to work out the kinks before we move to mass production. And that's one thing that we have excelled at, is the help and development of prototyping a project for specific customized needs. In this particular case study, the customer came to us. They gave us the basic information, of what they were wanting to convey, the size, weight, as well as a concept design. And after evaluation, we saw that the concept and the information they gave us was not going to be adequate enough to carry what they were wanting. And basically, we quickly came up with a more robust design that would support what they were wanting, as well as reconfigure some of the internal componentry and layout of this particular project that would make it even more cost effective to produce. So after we did the prototype, it was tested as usual and found to be successful. So we moved them into mass production on the part or on this project as well. So, I mean, this is some, go ahead. I'm sorry.
We just got a question, and the person asked, how did you find out that the weight requirement wouldn't work from the design specs that you were given?
Right. That's a good question. I failed to tell that. Obviously, with our Autodesk Inventor, we can do stress analysis on the materials that are going to be used. And we usually put in a 1.5 safety factor when we were doing this. Basically, with the design that they had, this particular project was about 12 foot wide, the part was, or this pallet was, and it was going to create a Boeing in the middle. And basically the parts were being conveyed on each end of it and would create a safety problem as far as parts falling off. So once we did the stress analysis, we had a pretty high level confidence that it would work, and of course tested it with the customer's help and found out to be successful in that design. So 60% of the customers choose to do prototyping with projects over $50,000. And this is basically, as we all know, it's in this industry, it's going to cut down on a lot of wasted time, wasted effort, and more than anything, wasted money. So that's why we really do our homework when we're working with a company as far as to suggest a prototype to get to form, fit, and function correct. So what does it mean to have a complex project? Moving parts, tight tolerances, needing an understanding of how it will withstand daily manufacturing rigors. And as I said, why many customers choose that: cost, time, risk. I will talk about one other project we had, and it's very, very important that what we tell our sales development people is understanding the scope of work, to make sure that we dig down even further to understand what it is the customer is needing and how it's going to be used. We just went through a project a couple months ago where the customer failed to tell us that a particular dolly was going to be used in a robotic operation and that they needed a tighter tolerance than was originally given to us. So after the prototype, we realized, you're right, it's not going to work, but here's what we can do to tighten that tolerance up. They gave us basically what they were needing was a plus or minus 1 millimeter tolerance on this dolly because of the use in a robotic operation. So we were able to come up with better weld jigs and fixtures that we hand machined basically ourselves to achieve that. So the scope of work and communication of that is very, very important, as we go forward in talking to each of our customers and understanding exactly what is needed and how it's going to be used so that we can provide repeatability on a production order.
Rich, we got a question. It said, to the extent of, have you saved a customer money through prototyping?
Yes. Yes, many times. I mean, if we would have gone basically, with certain customers' designs, there would have been a ton of rework that would have been required on many occasions. We've done that. Yes, prototype costs more. We understand that, but what it saves, especially on something that's going to be mass produced, where you may need, and what I call mass produced, could be 50 units, or could be, going back to the mother cart dollies, hundreds of units. If we had gone ahead and mass produced based on the original concept designs that were given to us, there would have been a lot of reworking going on there. So question, do you commonly prototype prior to ordering runs from contractors?
Oh, people are voting quickly. We'll have this open for just another couple seconds. Okay, I'm going to share the results now.
Okay, so the results are 63% yes, 25% no, and 13% voted I don't know. So obviously the majority of you that are in an industry where mistakes cannot be happening on a daily basis understand the importance and need of prototyping. So again, that is something that we understand, and we'll probably sometimes bug our customers to death, but we'll understand what it is they're wanting in the end. So, okay, Sam.
All right, let me exit out of this poll. All right, just a quick reminder. Valence Industrial is the combination of J.R. Buck Industries and HB Products. We combined just last year, where our CEO has done quite a bit of investing in the company, from new computers to new iPads on the factory floor, so we can actually track your projects through the process and give you stronger updates of the progress to date. We're getting quite a bit of investment, and when we're up against 60,000 fabricators, we know we need to be better than our competitors. And so when it comes to what's different, we'd say we're precise. We've got a new $1 million Trump laser. It's a beast of a machine. It cuts 1 inch thick steel and aluminum, 5 thousandths tolerance. It's a pretty cool machine. We just invested in OTC welding machines, so it's programmable, so you get the same heat and quality for longer runs. And then we have an AWS certified weld inspector to ensure that we're doing quality checks along the way. We're local with 79,000 square feet across our 2 factories in Sydney, Ohio, and Lexington, Kentucky. And both factories really have their own strengths. Sydney has been known for large structural welding projects, 18 feet by 18 feet projects, doing longer runs, larger projects. They probably do about 60 or 70% print to order, where the customer is providing a print. And then Lexington does quite a bit of work from just a concept all the way through production, heavy prototyping, and have done a lot of material handling projects, from dollies, carts, pallets, racks. But both of them have really been known to be able to step outside of what they're getting more work, and just be able to do highly customized, complex projects. Sydney has done the concept to the design of a medical device, a large burn victim unit bed, in combination with an electronics outsourcer. So that was a pretty cool project that was done recently. Lexington has done end of arm robotics. So we really are able to come to the table and bring expertise. And I think the last thing is just really being an expert collaborator. We've got manufacturing designers who always want to go and see the application of how things will work to find those efficiencies. And we always try to tout project management, so you're not cutting multiple POs, having to manage all the vendors to come together. We really can go from designing print and or from concept to part, all the way through finishing. We'd probably say that we specialize most in material handling, which we've spoken about today, racks, pallets, carts, safety for material handling from frames, mezzanines, platforms, all the way to large scale assembly and devices, and the forming of parts. So while we're flexible, we do have our sweet spots in the market. And I would just say to everybody, our engineers have so many insights and they are sharing their articles on a weekly basis, talking about case studies. So please do follow us on LinkedIn. Thank you guys for joining. Have a great day.